Elon Musk has recently unveiled the inaugural human implementation of Neuralink on Platform X, a landmark that signifies an important leap on the path towards a future where man and machine are inseparable. But what implications does this carry for us for our forthcoming days? Are we on the threshold of a cyborg uprising? Neuralink, a venture co-founded, is a business that specializes in brain-computer integration and has pioneered an intricate system endowed with a high bandwidth, designed to merge our mental capacities with the strength of technologies. It's a system designed to enhance and sift neural signals, pinpoint neuronal spikes, and evoke electrodes in groups of 64 at once. Imagine the possibility of compressing neural data and transmitting it through a singular gadget, such as the capabilities of Neuralink's technology. As we on the brink of this novel era, pondering over its repercussions becomes imperative. This technology holds the potential to revolutionize our existence in ways we've never known before, amplifying human abilities beyond our most imaginative notions. However, it also brings to light deep-seated questions about the essence of humanity. With Neuralink, we're not just discussing swifter internet or smarter phones. We're contemplating the potential to enhance human cognition, conquer neurological conditions, and pioneer new paths for communication and interaction. It's a prospect that's as exhilarating as it is intimidating. So, are we prepared to take on the future and evolve into cyborgs? As we delve deeper into the realm of Neuralink and its pioneer human implant, we cordially invite you to accompany us on this enthralling expedition. Let's embark. The initial human implantation by Neuralink wasn't a walk in the park. It was a complex operation involving a cutting-edge robot and patient zero, a courageous pioneer stepping into uncharted territory. This was a leap into a tomorrow where the boundaries between technology and biology blur in ways we've only dreamed about in futuristic novels. Patient Zero, the trailblazer at the epicenter of this narrative, was meticulously chosen based on particular prerequisites. This individual was more than just a patient. They were the first ever human to receive a Neuralink device implant their brain, a true pathfinder. The operation was a groundbreaking feat, an intricate pas de deux between human and machine requiring an unprecedented level of precision and control. A robotic arm, as rocksteady as it was accurate, was brought into play to conduct the procedure. This robot, under the guidance of a team of seasoned neurosurgeons, inserted threads as slender as a strand of human hair into the patient's cerebral cortex. The threads bearing the Neuralink device were scrupulously and safely implanted, exhibiting the precision of the robotic arm and the proficiency of the surgical crew. Once placed inside, the Neuralink device functions on wireless. It's a next-gen device available today. It's about the diameter of a coin, but don't underestimate its power due to its small size. This compact gadget holds the potential to transform the way we interface with technology and possibly even with one another. This surgery was more than just an implantation, it was about hope. Hope for a future where paralysis is a thing of the past, where neurological disorders can be controlled, where the human intellect can soar to new unprecedented heights. From the minute the operation was finalized, from the moment Patient Zero regained with a Neuralink device in their brain, the game was forever changed. We stepped into a new era of possibilities. This marked the beginning of a new chapter in human evolution. Well, what transpired post-surgery? How did the pioneer, Patient Zero, recuperate? As news, the groundbreaking operation went viral. The world anxiously anticipated updates on Patient Zero's situation. And then it came, the news we'd all been waiting for. Elon Musk himself verified the success of the surgery. The operation was successful, but the real cause for celebration lay in what unfolded next, the journey of recovery. After this life-altering surgery, Patient Zero embarked on a healing and acclimatizing process, learning to coexist with the revolutionary device embedded in their brain, a symbol of technological progress. The recovery was not merely about physical healing, but about learning to engage with the world in a completely new paradigm. In the initial stages of recovery, the Neuralink device showcased its prowess. It began picking up neuron spikes in the patient's brain, a crucial role in the realm of brain-computer interfaces. But what precisely are these neuron spikes? For the uninitiated, neuron spikes, also known as action potentials, are the electrical signals that neurons use for communication. They're like the brain's unique dialect. Whenever a neuron fires, it sends a signal to other neurons, which then triggers a domino effect, enabling the brain to process information, create thoughts, and direct the body's actions. The Neuralink device can detect and digitize these neuron spikes, turning the brain's electrical buzzing into a language a computer can comprehend. This is the core principle of Neuralink's technology, leading the way for the potential of mind-operated devices and software. Patient Zero's recovery journey was not just a tribute to the human body's resilience, but also to the promise of Neuralink's technology. It was a voyage filled with pioneering discoveries and a hopeful peek into a future where our brains and technology intertwine. The path to recovery was brimming with revolutionary discoveries. Imagine controlling your devices with just a thought. Welcome to the world of Telepathy Application. Neuralink's Telepathy Application is a cutting-edge software designed to interact with the company's N1 device, transforming the realm of human-computer interaction. This revolutionary technology aims to enable a user to manipulate their smartphone or computer using nothing but their thoughts. It's like having an invisible hand to swipe, tap, and type on your devices. This might sound like a plot from a science fiction novel, but it's a reality that Neuralink is working hard to achieve. The telepathy application communicates with the N1 device implanted in the human brain, interpreting and translating neural signals into commands that the connected devices can understand and execute. Imagine the possibilities. You could send a text message or make a phone call without lifting a finger. You could change the channel on your TV or adjust the temperature on your smart thermostat without needing to reach for a remote or a smartphone. But the telepathy application is not just about convenience. It's about transforming lives. For individuals with mobility impairments or neurodegenerative disorders, this technology could open up a new world of independence and interaction. It could allow them to engage with technology and the world around them in ways they might not have been able to before. Neuralink's mission, after all, is to enhance human lives, and the telepathy application is a key part of that mission, standing as a testament to the power of human ingenuity and the boundless potential of the human mind. The future is here, and it's more exciting than we could have ever imagined. As Neuralink continues to refine and develop the telepathy application, who knows what other incredible advancements are on the horizon? In the future, your thoughts could be the only remote control you need. What if you could restore sight to the blind? Neuralink is working on just that. The ambitious project has introduced an application called Blindsight, and Elon Musk has expressed optimism about its potential to bring back vision to those who have lost it. The technical process behind this is fascinating. It involves converting the digital vision captured by a camera into signals that the brain can interpret. Now, you might be wondering how this works. Imagine the camera as the eyes, capturing the visual world around us. This visual data is then transformed into electrical signals, much like how our retina converts light into neural signals. These signals are then fed into the Neuralink device implanted in the brain. But don't expect HD clarity just yet. The initial visual output might resemble low-resolution black and white images, akin to the visuals of early video games. However, this is merely the starting point. The quality of the visual output is expected to improve over time as the system learns and adapts to the individual user's brain signals. This is where machine learning comes into play. The Neuralink device is designed to learn from the user's brain activity, and with time it could refine the signals it sends to the brain, resulting in improved visual resolution. This breakthrough technology promises to open up a whole new world for those living in darkness. It's not just about restoring sight, but also about enhancing the quality of life for millions of people worldwide. The future of vision restoration looks promising, thanks to Neuralink. To better understand Neuralink, let's follow the journey of a neuron from analog to digital. This journey begins with the analog processing of neuron spikes. These spikes are essentially electrical signals generated by neurons, our brain cells, as a form of communication. But these signals are tiny and delicate, so they need to be amplified and filtered to be properly understood. This process has to consider factors such as noise, power consumption, and signal quality. From there, the journey continues with automatic spike detection. This step involves identifying and isolating the neuron spikes from the overall neural activity. The shape of these spikes is crucial, as different shapes can indicate different types of neural activity. This is where the transition from analog to digital begins. The identified neuron spikes are converted into digital signals, a process known as digitization. Finally, the journey concludes with every channel stimulation. This is where the digitized neural data is put to use. The N1 chip, the brain of Neuralink's system, can stimulate electrodes in groups of 64 simultaneously. This allows for a wide range of neural activity to be influenced at once, opening up vast possibilities for interfacing with the brain. This journey from analog to digital is not just a process, it's a transformation. It's the transformation of raw, organic neural activity into a form that can be understood and utilized by digital technology. It's a glimpse into the future of how we can connect our brains to the digital world. This journey reveals the sophistication of Neuralink's technology. From amplifying and filtering delicate neural signals, to detecting and digitizing neuron spikes, to stimulating vast swaths of neural activity, Neuralink is at the cutting edge of brain-computer interface technology. It's a testament to what we can achieve when we combine our understanding of the brain with the power of digital technology. At the heart of Neuralink is the N1 system on a chip. Let's delve deeper into its workings. The N1 SoC is a marvel of modern engineering and a testament to the ingenuity of the Neuralink team. It's designed to handle a plethora of tasks, from amplifying and filtering neural signals to automatic spike detection and channel stimulation. The N1 SoC is made up of three key components: analog pixels, analog to digital converters or ADCs, and a multiplexer. Analog pixels are responsible for amplifying neural signals. They play a crucial role in enhancing the quality of these signals and reducing noise. This process is vital as it ensures the device can accurately interpret the brain's complex language. Next are the ADCs. These convert the amplified analog signals into digital ones. It's like translating the brain's language into a format that machines can understand. The ADCs focus on characterizing the shape of the spikes in these signals, which is crucial for precise interpretation. The third component, the multiplexer, is responsible for data serialization and filtering. It's like a traffic controller, ensuring that the data flows smoothly from the brain to the N1 SoC and then onto the connected device. The multiplexer also plays a key role in compressing the neural data, allowing it to be streamed through a single USB-C connector. But how is the N1 SoC programmed, you ask? Well, it can be programmed via a scan chain or JTAG interface. This flexibility allows the Neuralink team to update and improve the system as they continue to push the boundaries of what's possible with brain-computer interfaces. The N1 SoC is a microcosm of Neuralink's technical prowess. It's a testament to the company's ability to fuse biology with technology, creating a chip that can understand and translate the brain's complex language. And while it's just a small piece of the Neuralink puzzle, it's a major step towards a future where we can communicate with machines using just our thoughts. As groundbreaking as it is, Neuralink's N1 SoC is not without its gaps. Neuralink's N1 system on a chip, or SoC, is a marvel in the world of brain-computer interfaces, but it's not perfect. This game-changing technology faces challenges that are as complex as the human brain itself. One of the key gaps lies in the analog processing of neuron spikes. This process involves amplifying and filtering neural signals, a task that must balance the dueling needs of minimizing noise and power consumption while maintaining signal quality. Tackling this problem is akin to trying to hear a whisper in a noisy room while using as little energy as possible. Next, we have automatic spike detection. This process involves converting and digitizing the signals with a focus on characterizing the shape of spikes. The challenge here is akin to spotting a specific wave in a turbulent sea. Neuralink is working on solutions to improve this process, but it remains a significant hurdle. Then there's the matter of every channel stimulation. The N1 chip is designed to stimulate electrodes in groups of 64 simultaneously, but this is easier said than done. Imagine trying to play 64 different notes on a piano at the same time, but with precision. That's the level of complexity we're dealing with here. Lastly, the ASIC chip used by Neuralink consists of analog pixels for amplification, ADCs for digitization, and a multiplexer for data serialization and filtering. The chip can be programmed via a scan chain or JTAG interface. However, this process is not without its challenges, as it requires precise programming and intricate engineering. Despite these challenges, Neuralink's progress is undeniably impressive. The company is making strides in addressing these gaps, pushing the boundaries of what's possible in brain-computer interfaces. And with every step forward, we edge closer to a future where the line between humanity and technology becomes increasingly blurred. Neuralink's technology has far-reaching applications. Let's explore some of them. The most immediate use is in the medical field. For people with paralysis, Neuralink's interface could restore physical mobility by allowing them to control assistive devices directly with their thoughts. The potential here is not just limited to wheelchairs or prosthetic limbs. Imagine being able to interact and communicate with the world around you just by thinking about it. It's like having a telepathic ability. But the promise of Neuralink goes beyond addressing physical limitations. It could also offer unprecedented ways to treat neurological disorders. Conditions like epilepsy, Parkinson's disease, and even depression could be better managed, perhaps even cured, by interfacing directly with the brain's neural circuitry. The potential to alleviate suffering for millions of people is truly profound. Beyond healthcare, Neuralink could also revolutionize how we interact with technology. We're talking about a future where typing on a keyboard or swiping on a smartphone could be as archaic as dialing a rotary phone. You could compose an email, search the web, or even play video games, all through thought alone. In the realm of artificial intelligence, Neuralink might allow for a symbiotic relationship between humans and AI. Instead of being left behind by rapidly advancing AI, we could essentially upgrade ourselves to keep pace. It's a concept that's as thrilling as it is daunting. Of course, it's important to remember that these are potential applications. The road to realizing them will be paved with technical challenges, ethical questions, and rigorous testing and development. But as we stand on the precipice of this new frontier in human evolution, one thing is clear. Neuralink's technology could change our lives in ways we can barely begin to imagine. The possibilities are endless. Neuralink's BCI is not just advanced, it's also user-friendly. Now, let's delve into the readability and user-friendliness of Neuralink's brain-computer interface, or BCI for short, and discuss its unique plug-and-play system. Neuralink's BCI is designed to be as readable and user-friendly as possible. It's a complex system, sure, but its design philosophy is rooted in simplicity. The BCI's interface is intuitive, designed to be easily navigated by users of all levels of tech know-how. This means that whether you're a tech enthusiast or a novice, you can engage with the system comfortably. But let's talk about the real game changer here, Neuralink's plug-and-play system. This is where Neuralink truly shines. This plug-and-play system is designed in such a way that the BCI can be easily integrated into the user's life. It's as simple as plug, play, and go. No complex setups or lengthy installations. This ease of use is a significant aspect of Neuralink's mission to seamlessly merge technology with human life. This approach is not just about making technology accessible, it's about making it practical. It's about ensuring that this cutting-edge technology can be realistically implemented and used in everyday life. After all, what good is a high-tech device if it's so complicated that it becomes a hindrance rather than a help? The plug-and-play system also speaks volumes about Neuralink's approach to data. The system is designed to handle large amounts of data efficiently, making the BCI not just user-friendly, but also robust in its performance. This balance between usability and performance is what sets Neuralink apart. So what we have here is a system that's advanced, yet user-friendly, complex, yet simple, high-tech, yet practical. This is the essence of Neuralink's BCI. It's a testament to Neuralink's vision of creating a future where technology and human life are seamlessly intertwined. Neuralink is not just about high-tech, it's also about high usability. This balance between advanced technology and user-friendliness is what makes Neuralink's BCI a true marvel of modern science and engineering. Every piece of technology needs rigorous testing. The N1 chip is no exception. As we delve into the world of Neuralink's groundbreaking technology, it's essential to understand the meticulous process that ensures its reliability and safety. The N1 chip, a cornerstone of Neuralink's advanced neural interface system, undergoes a stringent testing regime. This process begins with the analog processing of neuron spikes, a crucial step that involves amplifying and filtering neural signals. This phase must take into account considerations such as noise, power consumption, and signal quality to ensure the chip can effectively interpret these signals. Next, the N1 chip faces the task of automatic spike detection. This process involves converting and digitizing the signals with a focus on characterizing the shape of spikes. The ability to accurately detect these spikes is pivotal to the chip's functionality, allowing it to communicate effectively with the human brain. But the testing doesn't stop there. The N1 chip must also pass the challenge of every channel stimulation. This feature allows the chip to stimulate electrodes in groups of 64 simultaneously. This capability is vital for the chip's performance, enabling it to interact with a broad range of neurons and thus facilitate a wide array of potential applications. The testing process isn't always smooth sailing. Challenges arise as they do with any pioneering technology. However, these hurdles are not roadblocks, but rather opportunities for improvement and refinement. The solutions devised to overcome these challenges contribute to the robustness of the N1 chip and its ability to withstand real-world conditions. The N1 chip's testing process is a testament to Neuralink's commitment to safety and reliability. It's through this meticulous and rigorous testing that we can trust in the potential of this technology to revolutionize the way we interact with our devices and potentially transform lives. Through rigorous testing, Neuralink ensures the reliability of its technology. This level of dedication to safety and effectiveness is what sets Neuralink apart as they continue to navigate the uncharted waters of brain-computer interfaces. The surgery to implant the N1 chip is a marvel of engineering. Consider this: a chip no larger than a coin is being surgically placed into the human brain. This isn't just any surgery. It's a meticulously planned and executed process involving the integration of cutting-edge robotics with the delicate art of neurosurgery. It starts with the surgical robot, a machine designed to perform with an incredible level of precision. Imagine a surgeon with a never-ending supply of focus, never wavering, never tiring. That's what this robot brings to the table, but it's not just about stamina. The robot is guided by advanced algorithms, ensuring that the placement of the N1 chip is spot on, down to the last millimeter. The surgical robot is also equipped to handle the ultra-thin threads that connect the N1 chip to the brain. These threads, thinner than a human hair, carry the signals between the brain and the device. Inserting them requires a level of accuracy that's beyond human capabilities. The robot, however, is up to the task. It's able to avoid blood vessels while placing the threads, minimizing the risk of damage to the brain. Then there's the N1 chip itself. It's a masterpiece of miniaturization, packing a huge amount of technology into a tiny package. The chip contains thousands of electrodes, allowing it to interact with a vast array of neurons. It's designed to be robust, able to withstand the harsh environment of the human body, and yet delicate enough not to interfere with the normal functioning of the brain. But the real magic happens when the chip is activated. It starts communicating with the neurons, translating their electrical signals into a language that our computers can understand. It's a two-way street, with the chip also able to send signals back to the brain. This opens up a world of possibilities, from controlling devices with our thoughts to potentially restoring lost senses. This surgical procedure showcases the convergence of medicine and technology. Keeping the N1 chip powered might seem like a daunting task, but Neuralink has ingeniously integrated wireless charging into the design. The concept of charging a device implanted in the brain may sound like science fiction, but this is the reality of Neuralink's innovation. The N1 chip draws power from a wireless charging pad that's placed over the implant location. This eliminates the need for invasive procedures or awkward connections. It's as simple as charging your smartphone, yet it's powering a device that's revolutionizing our understanding of the human brain. The N1 chip is designed to be power efficient, meaning it doesn't require frequent charging sessions. This makes it user-friendly and practical for everyday use. The charging process reflects Neuralink's commitment to creating a seamless interface between humans and technology. It's not just about creating a device that can read and write to the brain, but also about ensuring that this device can be easily integrated into our daily lives. This method of charging also highlights Neuralink's focus on safety and convenience. By eliminating the need for wires or direct connections, they've reduced the risk of infections or complications. It's another example of how Neuralink is not just pushing the boundaries of what's possible with technology, but also considering the practical and safety aspects that are crucial for real-world applications. So, while the N1 chip may be at the forefront of technological innovation, it's also designed with a deep understanding of human needs and lifestyle. This balance between cutting-edge technology and practical considerations is what makes Neuralink's N1 chip a true marvel of modern engineering. Neuralink is pushing the boundaries of what's possible, paving the way for a future where humans and machines are more interconnected than ever. This remarkable venture, co-founded by Elon Musk, is not just a tech company, but a beacon leading us towards an extraordinary fusion of biology and technology. We've walked you through the journey of a neuron from analog to digital, delving into the complexities of the N1 system on a chip, or SoC. This chip, a marvel of engineering, is the heart of Neuralink's brain-machine interface, processing, digitizing, and transmitting neural signals with remarkable efficiency. We've explored the gaps in the N1 SoC, not as criticisms, but as opportunities for future advancements. These challenges are stepping stones towards a future where the line between the human mind and artificial intelligence becomes increasingly blurred. We've discussed the numerous applications of Neuralink's advanced neural interface system, from the telepathy software application that could enable control of devices through thought alone, to the Blindsight application that holds the potential to restore vision. Each application is a testament to Neuralink's mission of enhancing human life through technology. We've also looked into the surgical engineering behind the implantation of the N1 chip, a procedure that was successfully performed on patient 0. The success of this operation is a significant milestone that brings us closer to a future where such technology could become commonplace. As we've seen, Neuralink's technology is not merely about pushing the frontiers of what technology can do. It's about enhancing the human experience, expanding our capabilities, and opening up a world of possibilities that were once the stuff of science fiction. As we stand on the brink of this new era, we can only imagine the possibilities that lie ahead. Neuralink is not just about a new technology, but a new chapter in human evolution, a testament to our drive for progress and our insatiable curiosity. As we look to the future, we can only wonder, how will this technology change us? And more importantly, how will we change with it?